So it's actually a bit ironic for my talk to be right after the Google Cloud one, because I'm probably going to advocate for the exact opposite thing. Although, yeah, probably different use cases in a lot of things. But yeah, so my talk is about local first development, and actually the more extended title should be local first and open source first development, because that's usually what I try to use to take advantage of in my tools and how I build everything that I build, and we add some visual. And I want to start with probably a controversial claim that I think the way we build things is in many ways it's broken, and I'm going to explain a little bit more. But so first of all, when I say our, I'm not talking about everyone in the Ethereum ecosystem. So there's the Ethereum core development itself, the EVM and Solidity development. I don't work directly in those projects, so I don't know much about their development practices other than looking from the outside. I work mostly on smart contract development, front-end development for those smart contracts. So the products itself, protocols, things like Uniswap and so on. Lately, I've been involved with Liquidity V2, which just relaunched, and working with a couple of forks. So those sorts of projects that use Ethereum as their backend, and then they need their own front end for the end users to actually use. So there's people involved that are writing the smart contracts. People are building the front end. These people, they may or may not know how the smart contracts work. There's a lot of diversity in there. And then there's a lot of non-technical people that are involved in the project that they need to test the product. They need to test it with end users, which are another stakeholder. So all of these people are in some way involved in testing your product, your protocol. But a lot of the tools that we use, or I would say perhaps the best tools that we use, are only the ones that maybe the smart contracts developers and the front-end developers use and know how to use. And they're not, the more you go to the right, or to the right if, in this orientation, the easier or the harder or the less useful those tools become. Then I include mostly here because I don't want to be unfair. There's a lot of really good tools out there. They are really, really well made and have caused me no problems at all. But again, the more I go towards the right, the more I start having problems with these tools, and they're not just solving problems for me, but creating even more problems in my workflow. Problems from just not working correctly to not working correctly locally, which is what I wanted in the first place, or just downright introducing additional problems that I have to solve. I have a particular pet peeve with indexers, but oh well. So yeah, I think the way we use a lot of those tools, and the way some of those tools are built, or how they have to be used, and how they force us to work in order to use them, that whole thing is to me a little bit broken. And to give a bit more context, so before coming to Ethereum, I used to do traditional web development, mostly in Ruby on Rails and Elixir. You may not know these two logos if you weren't part of those communities. These were traditional backend frameworks or full stack frameworks for web development, even before React was the big player that it is today, back when we were still just doing non-SPAs, non-front-end heavy applications. And I mentioned these two communities because there was a big focus on both of these communities. They were highly related. Elixir kind of came from the Rails community. There was a big emphasis on developer tooling, and that tooling being comfortable and easy to use, not just for experienced developers, but also for anyone coming in. So if a new developer was coming into Ruby or Elixir for the first time, not only was the tutorial very well written, but the accessibility of the tools and the intuition about how those tools should work was very easy to get on. There was a lot of introductory courses. The Hello World kind of apps and to-do lists were very accessible if you had just very basic programming knowledge. Of course, this really can't translate to Web3 because the fact that we're using a blockchain by itself adds a lot more complications, but we can still do a lot better and maybe learn from a lot of the things that these folks used to do. There were a lot of principles that, yeah, people gave random names to random principles. This is just one of the principles I liked a lot, even though the name isn't really that catchy. The principle of least astonishment was just the idea that the tools or the system that you're using as a developer or as an end user, they should work exactly as you would expect them to work. When you click a button, you should already have some intuition about what that button is going to do. If it does something different or if it fails to work for some reason that's no longer intuitive, it maybe causes you to not use the product at all or to spend a lot of time frustrated trying to figure out what was wrong. And I think for developer tools in the Ethereum space, that's kind of my feeling of where we're at in a lot of places. So when using Ruby on Rails and then Elixir, I was used to very simple workflows. There was a one command setup. We used to have this kind of, not a rule, but we tried to enforce that every repo we worked on, a new developer coming into the team could just git clone the repo, run a single command that would set up whatever had to be set up, so just a single command, no need to read through a huge contributing guide, installing various tools and so on. One command that he was live, ready to develop. We had shared staging environment that was updated automatically. You could just go there and test whatever the current master version of the product was. And then we had live previews for every pull request with some fake seeded database so that whenever I open a pull request, the project manager or the user tester or so on could open a random web URL and start testing my product with an actual backend with the whole stack deployed for them. And most importantly, and this is kind of a given nowadays in web development, but back when Rails was maybe first starting, this was kind of a new thing, the idea that you could not have to compile your code and then go to a web page and refresh and finally see your changes. You could actually edit the code and almost in real time see that change reflected in how the front end or maybe the back end would work. That was a bit, it kind of ties back into that principle of least astonishment, because especially for newcomers to development, or in this case, web development, editing something in the code and having to realize that you may need to compile something to run a data migration, to refresh the page, those kind of things could sometimes break your understanding. And now when I came to Web3, I came to Web3 in 2016, 17, but still today I feel a lot of things are missing from that comfort that I had in Ruby and in Elixir. So now it's very hard for me to have that one command setup because there's just so many different tools. It's hard to have those tools work together. If I had a database or an indexer to my project, then the setup for that tool itself becomes a whole other project. Data management across all of those things, across a blockchain and an indexer, becomes a problem as well. Feedback loops are really hard to solve because now, if you're changing your contracts, you need to compile, deploy your contracts. But if you deploy your contracts, the address of the contract may change. You need to update that on the front end. So going from editing a contract to going to your UI and seeing how that change in the contracts affects the UI behavior, there's a whole lot of steps that you need to go through in order to test that. Test nets or public test nets like Sepolia and so on, they are meant to be the place where we create those staging environments and live previews, but they're really hard to use. First of all, finding testnet ETH is sometimes a big pain, especially if you're using the testnet to test with real users, because they may not even have a wallet set up, let alone testnet ETH. Interoperability is pretty much non-existent. If you're building a protocol that needs to interact with the, let's say, Uniswap or a specific token on Uniswap, and that token doesn't exist or doesn't have good support on Sepolia, then you need to deploy your own mock version. But then if you need to interact with a third protocol that doesn't know about your mock version, it's a whole problem it would only be solved if every single protocol would have their own fully supported version on that same testnet. Not to mention the UIs and so on. Once you get into subgraphs, because usually when you have a front end for your protocol, you may need a subgraph or some sort of indexer. Deploying a subgraph locally, it turns out, is not an easy problem to solve. Or I mean, it's easy in terms of complexity, but it's a big pain. And actually, I found out last year that even the developers from Subgraph, they didn't know about a few of the tricks I was using to deploy a subgraph locally, because it seems that only worked almost by accident, not as a first-class citizen. I may have a couple of tips to share on that. Managing the state of the subgraph is a problem in itself. Again, if you're redeploying the contracts after a change, managing the fact that the subgraph already had its own states can cause unintuitive problems as well. So these are some of the tools that I use, and probably people in similar roles as me, they also know or use these tools as well. Headerscan and DaughterScan are where you go to interact with the contract when you don't have access to an actual UI. You can go to a contract that's verified and interact with the source code. Again, the contract needs to be verified, which is kind of a limitation. Tenderly is really great for doing those same interactions, but seeing a full stack trace and being able to debug contracts more thoroughly, or simulating transactions before you execute them. Impersonator is maybe a less known tool, but it's a website that it uses Wallet Connect to hack your browser into thinking that you have a different wallet than the one you actually have. So you can go to Uniswap and connect using the address from Vitalik, for example. You obviously don't have the private key, but you can trick the UI into thinking that you have that address. You won't be able to sign transactions, of course, or sign messages, but you'll be able to see the UI in the state that Vitalik would see, which may be useful to, let's say, debug an issue that only happens for a specific user of your protocol, where you need to see his actual state. And the graph is how we deploy subgraphs, as I mentioned before. So all of these tools, except maybe DaughterScan actually, they have a very common problem. It's that they only work on live nets. If you're working locally, you're deploying maybe an Anvil node or Hardhat, you're deploying the contracts locally, you don't have them verified externally, maybe because you're not using a testnet or just because you don't want to publish the source code ahead of time, then you're kind of locked out all of these things. You can run a subgraph locally. Again, it's a bit of a pain, but it can be done. But you're locked out of all of these other things, except that you're only locked out of them because they weren't built to be local first. It's not like they have some magical feature that is only capable of working on a remote server on the cloud. Everything that they're doing is fairly trivial and can be replicated locally, especially the impersonator thing, which with Anvil is just a trivial thing that you get for free. So yeah, I think the typical Web3 tool, and I mean the tools from the previous slide and a few others. I didn't even mention wallets because there's a whole bunch of them and they each have their own specific quirks. Each of these tools is, I think, too powerful for low-level users. I think I meant end users in this slide, I think, not low-level users. So a lot of times I see non-technical people having to go to Headerscan and Tenderly and so on, and they don't really know what they're doing there, but they end up having to go there. And they're not powerful enough for us developers because they kind of do the work, but I wish they would have done it a lot better, and then don't allow me to do this locally. And yet, those are the tools that both sides end up having to use because it's the only ones that exist. And so I built, at the time, or during these past couple of years, ETUI, which somehow the lining of the slide was completely messed up. But this started as a wallet or a wallet replacement app that you would run locally. This is all built open source and it's already working. So this was, I think, one of the very first demos I did a couple of years ago, where I have the app running against a front end that I built as a demo. I'm clicking a button for minting. This is actually minting an NFT on this Anvil chain that's running locally. And one thing you can notice here is that as I'm clicking the button, I don't see a pop-up asking for confirmation as regular wallets would do, because this was on purpose in this case, because I'm using Anvil. In this case, I obviously don't care about security. I don't care. I'm actually using a plain text private key, because when I'm doing that kind of workflow where I just want to test the UI, I don't really care about security. That part just gets in the way. Having to click a pop-up and waiting for a simulation at every step would just slow me down. And minting this same amount of NFTs in that other workflow would take an exponentially longer amount of time. So this was one of the first quick wins. And again, this can be disabled, this fast mode is what I called, and you can still get the previous behavior if you want to inspect the transaction and confirm it before submitting. And obviously, it doesn't work. It only works when, on non-live chain IDs for security purposes. And then I added other features on top, such as this. From the terminal, this may not be very clear, but what I'm doing here is rerunning the script that deploys the contracts, and the wallet has a built-in kind of explorer that detects those contracts deployed in real time. Because this is all running on Foundry and Anvil, running on the same machine, I have access to the compilation outputs from Forge, and I can automatically match that this deployed contract matches this ABI. And then, as a result, I can also expose the same thing as others can with a fancy preview of the Solidity call that you're about to do. And this is all running locally just by scanning the file system, the compilation outputs from Forge, and essentially mimicking the same behavior that you would need. On either scan, you would need to deploy the contracts, verify them externally. Not only does that take time, it forces you to expose the source code and so on. And again, those iteration times become a lot longer. And I didn't mention, I don't have a demo for the impersonation side of things, because there's actually nothing to demo. You just go on the wallet, you create a wallet of type impersonation. Instead of a private key, you paste an actual address, and you just use it as it would be. Because being an Anvil node, you can get impersonation pretty much for free. So there's no wallet connect hack that needs to be done, no special behavior. You just say, I want to impersonate this address. And as long as you're connected to an Anvil node, that just works. And with the added benefit that you can actually submit transactions, because on Anvil you can do that as well without actually having the private key. And then this is the product, so to speak, that I finished a couple of weeks ago, or at least the first version. This is where I tried to solve the subgraph and other external tools side of things. So there's no UI for this. This is just something that works locally through a REST API, and then I'm going to integrate eventually into the UI of the app that you just saw. This can be run locally on our machine. It can be hosted on a server to share among your team. And the only thing this does is you send a post request to create a stack. In this case, I'm creating a stack called foo. I'm pointing to local.ety.dev. This is just an alias. If you know lvh.me, this is just a DNS record that points to localhost. So it's just a simple way to have the ability to use subdomains while still working in your local environment. It doesn't depend on any external server. It doesn't need to depend on DNS if you are offline. And by sending these post requests, you get a stack created for you. This is running on Docker behind the scenes, if that's relevant. And you get the foo.local, which is actually just an Anvil node. You can use cast, forge, deploy, and so on against it. But you also have a subgraph deployed pointing to that same Anvil node. You can deploy a subgraph to it. If you ever had to run the subgraph locally, there's a weird Docker Compose setup that is running out there. There's a couple of obscure environment variables that can be used to optimize the way that subgraph runs. That's all encoded there without you having to go through the same hours of research that I did. There's an explorer that we're also building right now that's it's not actually pointing to this node specifically. You can just paste the URL of the RPC, and it just works right away with any Anvil node. And right now that's it, even though there's a couple more components that we're trying to build as well, like a faucet and so on. The fact that the graph node is there also means that there's the Postgres database and IPFS nodes. Those are usually not needed. We don't need to interact directly with them, just through the subgraph, but they're there if you need them to, as well. And again, all of this is open source. If it's relevant, it's mostly built with TypeScript, Rust, and a bit of Elixir for this stacks part. It's all public on GitHub, and will always be there. Again, free and open source, and importantly, local first. So these are all tools that you can run locally in your system. You can modify them as you wish. You don't need to depend on any external cloud. You can host these stacks for your internal team. I've seen a lot of projects, including Liquid EV2, that they create their own private test net, which is just usually wiring together a few random scripts that then become hard to maintain and hard to replicate by other teams, because there's always very specific needs of how those things work. I actually had to go through a lot of those scripts in Liquid EV2 when I was trying to replicate their setup, and I had to go through the scripts manually to reverse engineer what they were trying to do. So this is just a quick way for you to get your stack running, either locally or privately for your team. And that's it. Thank you.
Thank you.
And I think we have time for questions.
Yeah, thank you, Miguel, for this amazing presentation. And we have a few minutes for questions, if there are any. I guess there are not. So thank you again.
Thank you.